This is the makeup video for the pressure, volume, and temperature lab. You should have this packet before starting this makeup video. So on our table in front of us are all the supplies we need for this lab. There are actually 4 stations in this lab, but all the supplies are here. Station 1, our syringe attached to our gas pressure sensor, attached to our LabQuest device. After that, for station 2, we'll attach the gas pressure sensor from the LabQuest device, detach it from the syringe, and attach it to the Erlenmeyer flask. For that, we'll use our hot water bath, our ice water bath, and our room temperature water bath. At that point, we will be done with our pressure sensor. After that, we'll need our squeeze bottle, along with some soapy water, hot water bath, and ice water bath. Finally, we'll test our pressure using our vacuum pump and a pressure pump on the sealed mason jar. So to start, read through your directions. I'm not going to read through them for you. I'll just demonstrate exactly what pressures you get throughout your data chart. So your data chart says, at a volume of 20 milliliters, what's the pressure? Then 18, 16, 14, 12, and 10. Here's my LabQuest. Easy to read. Before I attached my syringe to my gas meter, I set it to 20 milliliters. So it's already at 20. So that 101.7 is your first data point. I'm now going to depress my plunger to 18. 119.4. Going to go to 16. 126.3-ish. The numbers will bounce back and forth pretty consistently, but you just pick one. Looks like 126.22 is where it's staying at. It'll bounce back and forth a little bit. You can choose the one that it seems the most consistent at. That was at 16. Now we're going to 14. 14, the pressure is 142.93, let's say. Going to 12. Pressure is at 164.23, 24, 28. Whatever you'd like to write down. Last one, pressure of 10, 197. Again, it's hard to hold it right here. It's going to flutter back and forth a bit. Let's say 198.5. Again, you can go back and rewind and look at those pressures and volumes as you go. That should all make sense if you have read the directions. After that, graph. Answer your questions. You've got your type of pattern. That's going to be either inverse, quadratic, or linear. General equation that goes with that. Follow these steps. Should be able to finish that no problem. All right, on to experiment number 2. Again, I am just going to perform the data collection. It is up to you to identify the independent variable, dependent variable, and the constant. All of our variables and constant in this activity are going to be either pressure, volume, or temperature. So ask yourself, in this experiment, when I read these directions, what am I going to change? What will be changed because of what I change? And whatever's left of those 3, pressure, volume, and temperature, that's going to be your constant, right? This is a hint right here. Temperature and pressure, those 2 will change. So of the 3, temperature, volume, and pressure, which one is clearly going to be your constant, right? Okay, straight to the data. You read through the procedure if you need it to make sense to you, okay? Changing out our apparatus. Now our sealed Erlenmeyer flask is attached to our pressure sensor. If you're wondering why our pressure started at 101 in the last experiment, it's going to be at 101 at normal room pressure. That is the normal gas pressure, air pressure in the room in every room in Albany. So again, we're starting out here. This is at room temperature right now, but we can verify that right over here by putting it in our room temperature bath. Then we can go to our ice bath, then our heated bath. First, we're going to get our temps. Our room temperature water is at 24 degrees. That might be hard for you to read. It is 24 degrees. Our ice bath is at 4 degrees. Again, might be hard for you to read, so that is at 4 degrees. Our heated bath is at 4 It is dropping rapidly, so I'm going to put it back in really quickly. I want to know the heat of the water in the bath, not with it dropped. Okay, it seems to be back up to temperature. And it is at exactly 90 degrees, but it's going to be dropping pretty rapidly right when I take out the thermometer. So, in the bath, it was at 90 degrees. I'm going to remove all my thermometers now, set them to the side. Based on the order of the data chart, we're going to go with the ice bath first. Ice bath pressure. I'm going to leave it in the ice bath for a minute or so. Allow the pressure to adapt. You can see our pressure is dropping. We're going to wait until it stabilizes. It doesn't look like it's dropping anymore. All right, so I'd say our number here is probably around 96.5 to 97.0. Any number in that range would be a logical number to write down on your sheet. So you should already have the temperature from the video below. If you did not get that, go ahead and rewind. And then 96.5 to 97 for our pressure. Next on our data table, it says go to room temp. Here we go. You can see our pressure is changing fairly rapidly here. Looks like it's holding pretty strong around 103.4. It's hovering back and forth, 103.3, 103.4. There you go. And our hot water bath. All the way down to the bottom here. Sorry for the delay there. My seal got a little bit loose. Our pressure is continuing to rise. Going to keep holding it until our pressure levels off. Looks like our changes might be slowing down a little bit here. I think it's about where it's going to get, 109.6 something, 109.6 something. It's kind of vacillating between 109.6, 109.5. Either of those would work. Again, sorry for the delay. My seal was a little bit loose. All right, so that is all of the data for experiment 2. If you did not get all that data, you'll have to rewind the video and watch again. Experiment 3. This one, we're going to use our bottle and our soap. This one will go a little bit faster. You do data and sketching for this one. No graphing. You'll answer some questions afterwards. In this one, we take our bottle. This is a squeezable wash bottle. We dip it upside down in the soap. Make sure we have a film, a small bubble film over the bottle. We watch what happens when we put it in hot water. As you can see quite clearly, the bubble increases in volume. Then we move it to the cold water and watch what happens to the bubble. The bubble immediately starts decreasing in volume and will in fact shrink down into the bottle, so that if you could see it up close, what you would see is the bubble inverted in the mouth of the bottle, curving downwards, the opposite of the shape when it was in hot water. That one goes pretty quickly. All right, finally we have our jar with our balloon in it. So these, you just sketch what you saw. If you need to rewind and go back, you sketch what you saw. Ice bath temperature, room temperature, and hot are the exact same as they were for the previous lab. They did not change. Use those previous temperatures. Lastly, we have our vacuum and our air pump. We're going to start with our vacuum. Remove the lid. Need to measure our balloon under no pressure change first. So we're looking through our jar here. Measure the diameter of the balloon. Right in front of you. You can see the diameter is around 4.5. We will apply our vacuum by sealing our vacuum pump on here, holding it tight, and watch what happens. Vacuum pump is working, and what is the balloon doing? It is increasing in size. Your vacuum pressures are already listed on your sheet for you. This pump goes to a maximum of negative 12 psi, or I guess I should say minimum. Okay, looks like it lost its seal right at the end there. But as you can see, it filled the entire jar. So if we measure the width of the entire jar, we go to about 6. So we started at 4.5, we went up to 6. Lastly, we are going to pressurize our jar. I'm going to add my cap back on here. Go get my pump. Standard bike pump. Sealed on. I'm going to move the bike pump so that you can see the jar quite easily. Make sure this is tight. As I add pressure, again, observe what happens to the balloon. See if our seal could get a little bit tighter here. Our balloon is shrinking. The hard part is seeing what its smallest size is. That's what we actually want to observe. It is under some pressure right now, but we want to observe the size when it is at its very highest amount of pressure. So I'm trying to watch and see what the smallest it will shrink down to is. And it looks like the lowest it got was about 3.5. So under no pressure, we were at 4.5. Under vacuum of 12 psi, we were at negative 12 psi. We were at 6 centimeters in diameter. And under our positive 15 psi, that's the highest that the seal on this cap will let us go, we were down to about 3. Actually, it's sealing a lot better now. Let's see where we're at. Definitely 3. Wait, we said 3.5. I apologize. Yeah, 3.5. You can tell that it's much smaller. As I release the pressure, you'll see that it'll increase in size a little bit. Back to its normal state. You've now acquired all the data you need for this entire lab. It was kind of a long video, but the lab took a lot longer. The lab was also more fun to do in person, but that's all the data you need to complete this lab. If you missed any of the data points, I promise they were all in there. You're just going to need to go back, rewatch the video, get all your data points. That's all. Thanks a lot.